to this computer. Okay, so now we start recording this session, this morning session. We have as a first talk today, we have Maria Bervida, and she's a researcher at our Center for Atmospheric Research, and she will tell you a bit more what she does, of course. So today, as I was telling you before, here we represent the School of Science at the University of Gorica. And for this European Researcher Night, we will have the pleasure to hear 4 different presentations by 4 different researchers, when the topics are quite diverse between them. Yes, so let us start with Maria. She will tell us something about the Bora wind, of course, which is influencing our daily life here in China. So I think it's very important that we hear some interesting things about the Bora wind, but not only, also what kind of research is being done here locally. So yeah, Maria, please go ahead.
Okay, thank you. So today we will talk about Bora wind. So let's start first with what is Bora. I'm sure that all of you from Slovenia are familiar with it, and you know that this is a strong and gusty wind. So what is special? It's not just strong but gusty. What means gusty? It means that it doesn't blow constant, but it blows in some gusts, which may be also periodic, like every 5 minutes. And these gusts can reach even 5 times bigger values than the mean wind speed. So the greatest measured gusts were above 200 kilometers per hour. And what is characteristic for Bora is also that it is variable. So it has variable frequency and duration. So Bora appears more frequent and lasts for more days during cold season, so during winter, while it lasts shortly and appears less frequently during summer season. So Bora is actually a cold and downslope northeast wind. What means the downslope? It means that the cold air masses are forced towards some barrier, let's say mountain, down the slope where Bora also accelerates. So for example, here in the Pava Valley, when Bora is incoming from northeast direction over Trnovski Gozd Ridge and down the valley and flows down the valley where it reaches high wind speeds. So why is Bora important to us? Because it affects our life in many, many different ways. So from causing economic damage, like here, we can see the effects of one Bora wind episode in the Pava Valley when Bora break the doors of building. It can also break and carry away, which is dangerous, the traffic signs. It can break trees and also uncover roofs, damage chimneys. There are a lot of effects of Bora. So we can also see in the landscape when we look around how the trees are deformed. Then in agriculture, it may affect agriculture also pretty much because it takes away the fertile soil and also the moist from the land. And also it may be very dangerous for traffic. We know here when we have stronger Bora events that the traffic is limited for big trucks and also the speeds are limited for other vehicles. Okay, so because of these effects and to prevent somehow the economic damage, we saw here that a lot of houses has on their roof stones, so to prevent Bora from lifting up their roofs. So it's important to know Bora and to predict possible strong wind events so that we can prevent the damage. So when does Bora appear? So in order for Bora to appear, we need to have a particular set of conditions, which means that we need to have either the weather on a large scale. So this particular synoptic situation means that the weather on a large scale, for example, over the Europe, need to be special, and also we need to have high orographic barriers, which are, for example, mountains. Or Bora may appear when we have a passage of a cold front. So, for example, if we have a low pressure center over the Adriatic Sea, then in this case we get cyclonic Bora. It's also called cyclonic Bora, and the weather condition in that case are cloudy and there might be some rainfall. Well, while the Bora is driven by high pressure cell over Central Europe, then we have so-called anticyclonic Bora, and in this case we have clear skies and clouds may appear just over the crests of mountains. And also Bora can appear in a combination of both of these conditions. So where does Bora occur? Bora in Europe, Bora occur on the lee side of Dinaric Alps, so along from north to east Adriatic, and in Slovenia it is the strongest in southwest region. But the cold downslope windstorms, such as Bora, so which are caused by the flow of cold air masses over mountain barriers, may also appear at other locations around the world, such as in USA, in Russia, or in Japan. And as we said, in Slovenia, Bora is most common in the southwest part, where it is the strongest in the Pava Valley. So on this picture, we can see the orography of the Pava Valley, and these mountains which surround the valley make perfect settlement for Bora appearance, and they give a rise to Bora. Okay, so this is just one example of Bora situation in Ajdovščina. This is the picture taken in the valley, and we see that skies are perfectly clear, and there is just one cap cloud above the crest of mountain. So this is like typical Bora weather, let's say. Okay, so how can we observe Bora? So we observe Bora by the measurement of wind field, which means that we observe its wind speeds and wind direction. So here we can see just one example, one graph which shows the wind speeds during Bora event. So here we have 1 second and 1.5 minute data. So 1 second is really high sampling rate, which means that every second we have Bora wind speed data. And this kind of measurements we can use to investigate Bora gust. As we said before, Bora is very variable, and one moment it can be low, and at the other moment it will it will be very, very high. It will be very high value of the wind speed. So for investigating gusts, it's good to have high resolution measurement. But for example, for prediction of weather and for weather forecast model, we use the average value, so in some interval, for example, 1.5 minute interval. Wind direction we can represent by wind roses, as we can see on the picture. So here, what does this wind rose says about the wind? It says that the wind is blowing from the northeast direction, and this wind rose is typical for Bora. So Bora in general occurs from northeast, but also it can have some other direction depending on local topography, so on how these mountains are arranged in local scale. So how do we obtain this kind of measurements? We can obtain this kind of measurements on two different ways. So there are two kinds of measurement techniques: on-site and remote sensing technique. And for example, on-site technique are techniques that we measure the atmospheric variables directly. And these are usually point measurements. For example, here we can see the instrument for measuring Borah wind speed and Borah wind direction, and we get these values in particularly this point of the atmosphere. So this is wind, this is cup anemometer and wind vane for wind direction. So from this kind of measurement, we get Borah, for example, Borah wind speed in one point of the atmosphere. If we want to get better picture, so let's say some height profile, we can use weather balloons. So weather balloons, they may provide us wind speed at different heights, and also they carry other instruments, so they provide us also the temperature, pressure, and humidity. But the thing with weather balloons is that they have poor spatial resolution, which means that, for example, in Slovenia, there is only in Ljubljana, the weather balloons are launched only from Ljubljana and just twice per day. So then there is another kind of measurement technique, remote sensing, in which we can get far more points than by point measurements. For example, this is remote sensing instrument called LiDAR, and it can measure, as we can see, for example, in this picture, in vertical range of the atmosphere in many different points. But of course, there are some different, because these kind of measurements are volume measurements, and these kind of measurements do not measure directly variable, but they use some signal which is either sent to atmosphere, either from natural source like sunlight, which is then reflected back to instrument in order to obtain this variable which we are interested in. Okay, so at our university, we used for Borah research, we use a different instrument to investigate. So we use an anemometer, which gives us point measurement, which is set up on the rooftop of university building in Ajdovština. So this kind of anemometer uses sound waves to determine the horizontal wind speed and direction, and also what we have, the remote sensing instrument. So on this picture we have a wind LiDAR, which was here for some 1 month, and we use it to obtain the wind speed in the range from the floor to 200 meters above the valley, in this vertical range, which we would do hardly with this point instrument. Okay, so another instruments what we have are also two different types of LiDAR. So as said before, LiDAR is remote sensing technique. What does it mean? It means that in our case, we have similar principle of work. LiDAR is composed of the emitter. For example, we have the laser, which sends signal to the atmosphere. Then this signal is reflected of the tiny particles in the atmosphere, which are called aerosols, and reflected back into the receiver, which is this big telescope. And by using different kind of lasers, we can get different information from the atmosphere. So this LiDAR one is placed at Otlica. I don't know if you know where Otlica is, but it's located at the mountain above the Vipava Valley. And at Otlica we also have observatory, which is used also in research purposes and also in meteorological purposes, for example, for ARSO, and this data is then used in weather prediction models and so on. And here in the valley in Ajdovština, you can see second LiDAR. What we have is placed in the university building, and it looks to the roof. So with this kind of measurements, we can get the picture of how the atmospheric flow looks like. For example, in this picture, we see how, for example, during Borah, atmospheric structures look like. So here we can notice that they are somehow periodic and repeating, like some little waves. Okay, and to summarize, so all these measurements, for what we use them, so of course we use them to investigate and describe Borah more properly. Although Borah was studied for decades, it is still not fully understood, its mechanisms, and also it's not fully described, because sometimes Borah may depend also locally, so the Borah's properties. So we can use this kind of measurements to look how mean and turbulence characteristics of Borah wind are, to see their predominant direction at particular local places, and also to observe some atmospheric structures which appear during Borah and other properties. Like, for example, this graph shows the Borah profile, which was studied when we had the measurements at 4 different heights in Razdapta. And why this kind of measurements and this kind of data is important? Because we need to know the profile so we can advance our weather prediction models and also other models which are needed, for example, to study how Borah may affect some buildings or bridges, what we want to build in Borah affected region. So for this, we need those kind of informations. So as I said, Borah characteristics aren't still completely described, which means that we need to do more investigations and we do more measurements and study Borah. And also, as Borah may vary with regards to different seasons, for example, in winter or in summer, with location, so how at some location the mountains are different range, the direction is different, and also regarding to synoptic situation, there are difference in Borah's characteristics. Okay, and for the end, there is one interesting legend which says that here near Ajdovščina in the Vipava Valley, at 4th century there was a battle between Eastern and Western Roman emperors, Theodosius and Eugenius, and actually Borah wind helped to win the battle for Eastern Romans. So at that time, also not just Borah, but also there was a rain caused the local flooding or river Hubel, plus Borah appeared, strong Borah, which was blowing in the face of these Western Roman emperors and the army. And it said that their projectile weapons was useless. So when they hit arrow, this arrow, because of Borah, flew back at them. So this is just one legend, and which, according to which the Christianity was secured here in the. And also there are a lot of jokes about Borah, especially, I mean, in Ajdovščina and in this part, Borah is somehow normal weather condition, and in other parts it's so not so. It's in Slovenian, so you can read it. Okay, so that's some short introduction and about the Borah.
Nice preluftajo. Great. Nice way to finish.
Okay, thank you. If you have some question, you can ask.
Yeah, so please go ahead if someone has some question to ask for Maria, just go ahead. Otherwise, I will start with a question. I think this is a very interesting topic. Please go ahead. If not, okay, I will start. So, I'm curious. So you say so this wind is very particular for this region. But so you said the main reason is the fact that you have this high, well, not so high, I guess,
Yeah, it's
mountains.
not. Uh-huh.
And then there is the valley, so it's like the wind goes down and gets accelerated in some
Yes,
way.
yes.
But I guess what is the why is it so particular? Is it because the sea is nearby as well, or what makes it like so special
Yeah,
and so strong?
the so strong. I mean, the trigger. So we have the situation on synoptic scale. So we have in Europe, I don't know, high pressure over Central Europe or low pressure over Adriatic, and also depending on how the difference between this pressure is, we have the difference in wind speed. But what triggers also Bora is the orographic barrier, which means high mountain. And in this case, we have the mountain above the valley, which is over 1,000 meters. And then this cold airflow is forced, and which is denser than the rest, is forced over this barrier. And then due to the gravity, it also accelerates down the slope. So also the orography around the place is very important for Bora appearance. Also, like when we see where Bora appears, so it appears just on the lee of Dinaric Alps. So on this side, where we have these mountain ranges.
And also, do you see like some pattern during the day? Is it more common in the morning or in the evening? Because I guess the atmospheric pressure also changes during the day. Do you see like some kind of pattern or?
So there are, I mean, different types of Bora, which patterns also depends on that. But
there's a dark Bora and then the lights.
Yeah, the light Bora, and there are, according to different authors, they divide it into different types. But
there's Borino, a little Bora. I heard at least in Trieste.
Like that. This is like in our country, they joke like in Istria there are like 7 kinds of winds, and in the central Croatia, like when it's just blowing, it's just wind.
Yeah, very exciting. And then this battle that you mentioned, is that the Frigidus River? It's that the Vipava River, right? They think it is, like historians, or I guess this is a history question.
Yeah, this is history question, and also there, I mean, there are a lot of like doubts where exactly was the location. So I mean, it's something we cannot know for sure.
Yeah. Okay, so any other questions from the other participants? Yeah, curiosity. Well, or anything, perhaps Leah, if you are curious to learn something about the Center for Atmospheric Research, we can ask now. Maria. Otherwise, we can close our session here. And we can, and then we continue at 9:50 with our next presentation, which will be given by Erika Tomšić. And since our theme today is virtual scientific snack, you have seen that Maria talked about, does Bora stop for lunch? And the next one is, as I said, by Erika Tomšić, and she will talk about how you can make a sandwich from graphene. So I'm also very excited to hear the next talk, so I hope you will join me later as well. All right, so see you in 20 minutes. Bye-bye, everyone.
Thank you, goodbye.